Okay, 8.6, you're going to find out what a common log is. The only difference between 8.5 and 8.6 is that all of the bases are 10. So on the ACTs, if you don't see a number down here, it's automatically a 10. And since it's a 10, you can just use your calculator. So take out your calculators. And over on the left-hand side, you should be able to see the LOG button. So hit the LOG button and hit the 5 and put a parenthesis after it and put 699, go out to 3 decimal places. Try it again. Hit the log button, hit 14, finish the parentheses. 1.146. So that's the first part. It's just knowing that your calculator has a log button on there, and that your calculator only works in base 10. Okay, in order to solve this problem, I am going to rewrite it back into the form of a log. So the log of 3 of 15 equals, oh, not that. I'd rather do it a different way. All I'm going to do is log both sides of my problem. Right there. In order to get the x back on the ground, I have to log both sides of my problem. Everybody see what I did? If I logged one side, I just logged the other. In order to get x alone now, all I'm going to do is divide both sides by the log of 3. So all you have to do is take the log of 15 on your calculator and divide it by the log of 3 on your calculator. And you're going to get 2.465. So the second part of this assignment is logging both sides. Now let's do a couple more. Log of 4 to the x equals the log of 7. I can take the x and I can put it out in front so it's no longer up above. So x is going to equal the log of 7 on your calculator divided by the log of 4 on your calculator. Which is 1.404 to the nearest 3 places. One more. The log of 6 to the x equals the log of 13. It's okay, we can do this because whatever you do to one side, you can do to the other. You can take that x and put it out in front. So x is going to equal the log of the log of 13 over the log of 6. Okay, couple more. This one's a little bit more difficult. I still have to log both sides. Okay, this is a little bit more trickier. Do you see that there's 2 things in there? So it's just going to be the log of 5 equals, and I want you to put that in parentheses. So all you're going to do is get rid of that by dividing both sides by the log of 2. Whatever you do to one side, you do to the other, just like you've been doing. So you get the log of 5 divided by the log of 2, and you get 2.322 equals x minus 2. The only difference is you have an x minus 2, and then all you do is add 2 to both sides, which makes 4.322. So you're doing the same thing. You're going to log both sides. See that? You're still doing the same thing. You're just going to move this out in front, but if I were you, I'd put that in parentheses. Get this alone by dividing by the log of 7. These will cancel out, so you're left with x plus 1 equals the log of 4 divided by the log of 7.712. But in order to get x alone, I need to subtract 1. So 0.712 take away 1 is going to be the answer. Final answer. And the last part of today's assignment. On the ACTs, your calculator only works in base 10. Do you see that there's different bases? All you have to do is to take the bigger number and put a log over the smaller number on the ACT. So if you see the log of base 3 of 7 on your test, all it is the log of 7 divided by the log of 3, which is 1.77. Do you see this on the ACTs? It's just the log of 9 over the log of 4. Which is 1.585. Final answer. And that's all the notes for 8.6. Definitely using your calculator on every problem.